Hello and welcome back to another episode of Math with Sohn. Today we are going to be talking about a midway point between polynomials and going over and reviewing it. So I got several problems printed out that we're going to deal with. The first one is asking about the degree and the leading coefficient of this. So you have to pay attention to the way that it is presented and also be very careful because this one is especially different because the leading coefficient would have been either 2 or 13, but notice how both of those are x to the 7th? Well, if you have 2x to the 7th and negative 13x to the 7th, they combine to make negative 11x to the 7th. And the 11 is going to be, the negative 11 is going to be the leading coefficient. And the degree is going to be the 7. So the degree is going to be the 7 because that is the biggest exponent. And you just had to be careful because there were 2x to the 7th, so you had to combine them first. They were trying to trick you. All right? Next one. Compare the end behaviors. So when you're comparing the end behaviors, then you got to take like what's going on between both of these. So if we take the 5x to the 4th, the negative 5x to the 4th, if we graph that, it would look something like this. It would kind of do some squiggles, and it would be kind of looking like it's ending in a negative direction on the left and the right. And if we graph the negative 2x to the 3rd, that one would be going down from left to right with some squiggles in the middle. So the way that you're going to compare that is you would say as x approaches infinity, they are doing opposite things because, negative infinity. On the left side, negative infinity, see how that like negative infinity, they're doing opposite things because on the left side, we're going down over here, but we're going up over there. And this would be the left, and this would be the left, and that's what we're talking about here, the left side. That's the left. But on the right side, as x approaches positive infinity, they are both going down. So as we are going to the right side, they are the same. And that would be how it would be worded and how you would need to understand it. For some things, you could also just write the entire end behavior if you wanted to. All right. Next up on the table, no pun intended, we have a table. Okay, when you're determining what is going on with this table, then you need to look at it, and you have two choices. You can plot every single one of these points real quickly, and when you plot every single one of these points, you would plot -6, -3, dot. You don't have to be perfect. And then -4, +5 up here. -1, 13, a little higher. If we started connecting the dots, we would end up with something like this. At 0, we start going down. We're at 5, so it would start going down. And then at 2, we're back up at 7, which tells me that it changed direction, which maybe there was a 0, but we don't know for sure. Maybe it only dipped down to right here. And then we could plot the point at 5, and we'd be at -1, so it'd be down here. It went downward. And then at 2, at 7, we're back up at 6, way up here, so it's going back up at 6, at 7. And then at 8, we're way down here at -13. You can see how graphing takes a little bit of time, and it looks ugly. And then at 10, we're at 21, way up here. Okay? But it does work, and you can count 1, 2, 3, 4, 5 guaranteed zeros. Now, an easier way to do it is to quite literally just look and say, all right, how many times did we change from positive to negative? And this would be 1 time from here to here, from -3 to 5, that would be 1. And then we did another change from 7 to -1. That'd be another. And then another change from -1 to 6. That'd be another. And then another change from there to negative 13, that'd be another. And then another change from negative 13 to 21, which is why it kind of there at the end, because we had a lot of sign changes. And then you could add it up, 1, 2, 3, 4, 5, 5 guaranteed. So however many times it goes from negative to positive and then back to negative and negative to positive, it'd be that many guaranteed zeros when you're doing it, okay? So that's another method that you could utilize to determine it. All right? Next up, this one's a little easier. Evaluate. If it's a minus in between, you need to make sure that you distribute the negative to all of those terms. Change the sign, change the sign, change the sign, change the sign, and then combine any and all like terms that you have. Well, I sometimes like to rewrite the original right here. And then after you've changed the sign, you would be adding all of this stuff. So this would be 5 and negative 7 makes negative 2. And 3x to the fourth and 3x to the fourth makes 6x to the fourth, not x to the eighth. You do not add your exponents. 4x squared, not 4x squared, 4x and negative 4x, they just cancel each other out. And be careful, I almost forgot my squared here. 7x squared and negative 8x squared makes negative 1x squared. You do not need to write the negative 1 in front of it, but you can. You're not, going to be shamed for writing it. Next page. This next one is perhaps one of the harder ones. You got grass that's being laid around a perfectly square house. And it's a rectangular plot of land around this house with the length of the grass is 4 more than twice the length of the house. So if we have 4 more than twice of something, that would be 4 plus 2x. So that would represent the length of the grass. And the width is 6 more than the house, so that would be 6 plus x, or you could write x plus 6. All of those represent the same thing. And the house side is x. So we're going to FOIL this out. We're going to have to FOIL this out. 4 times 6 is 24. 4 times x is 4x. 2 times 6 is 12x. And 2x times x is 2x squared. Combine any like terms. We got 24 plus 16x plus 2x squared. Now here's the thing that a lot of people forget. We want to find the expression for the area of grass if the side of the house is x. So we only want the grass. So this grass is like embedded with a house in the middle, essentially. So what you need to do is you need to also, if we only want the grass, we have to take this house out. So if you have to take this house, we've already found essentially the area of the house, or excuse me, the entire plot of land with the 4 plus 2x and the 6 plus x. That's difficult for me to say. 6 plus x. You got to take the house away, which the house is just x times x. So you would subtract the x times x, the x squared. Which, if you do that, you get 24 plus 16x plus 2x squared minus 1x squared is 1x squared. And in most cases, you would also have somebody appreciate if you were to write it as x squared, then the 16x, then the 24, rather than just the reverse order. Next one on the list, we got find an equivalent expression for this. If you ever see x plus 3 to the negative 1 power, anything to the negative 1 power, and it's only to the negative 1 power, typically that either means inverse, which isn't this chapter at all, or divide. And if it's dividing by the basic boring factor, which one of my students is calling the BBF, basic boring factor, you would change the sign of the negative 3, and then you would put these numbers, the 5, the 6, and the 5 here, but if you're missing any terms, you got to put a 0, and we are missing an x squared term. It goes straight from x to the third to x, so you need a 0x squared, so that's why I have a 0 here. You bring down the first number, 5. You multiply 3 and 5, you get negative 15. You add 0 and negative 15 makes negative 15. You multiply 3 and negative 15, the negative 3 and the negative 15, you get 45. 45 and 6 makes 51. Multiply negative 3 and 51, you get negative 153. Add straight down, negative 5 and negative 153 makes negative 158. Whatever you start with, if I started with an x to the third, I drop by one exponent. So it was x to the third, now it's x squared. Minus 15x plus 51. And then your remainder, which is the last number, divided by the original x plus 3. The big thing you got to remember is change the sign of the 3 to negative 3. And make sure you drop the exponent from x to the third down to x squared, as well as any missing terms you may have. Getting right along. We're moving right along, ladies and gentlemen. We got a few more to go, though. A few more to go. Oh, this one didn't print very nicely. If we divide this stuff, which goes back over to here, by the 2x squared y to the third, this is not going to be synthetic division because you're dividing by a monomial, and it even has kind of monomial here. You would need to divide everything, 8x to the fourth, y to the sixth, everything individually get their own 2x squared, y to the third. Then the 20, x to the sixth, y to the 10th, over its own 2x squared, y to the third. Then the last part, the 10x to the fourth, y to the fifth, which kind of printed down here, the 10x to the fourth, y to the fifth, over its very own 2x squared, y to the third. So everybody gets a 2x squared and a y to the third. You divide individually. 8 divided by 2 is 4. Subtract your exponents. 4 take away 2, you get 2. 6 take away 3, you get 3. 20 divided by 2 is 10. X to the 6th take away 2, you get x to the 4th. 10 take away 3, you get y to the 7th. 10 divided by 2 is 5. Oh, whoa. It was a negative 10. Negative 10 divided by 2 is negative 5. 4 take away 2, you get x to the second. 5 take away 2, you get y to the second. All right, so let's see which one of these answer choices are actually here. 4x squared y to the third, A. 10x to the fourth y to the seventh. Oh, nope, they didn't include it, and that's okay. You're selecting all that would be there, but it doesn't necessarily have to include all of them. Negative 5, I almost missed that negative. Negative 5, x squared, y squared, D. Okay? Keeping the trend alive, continuing and getting this video done for you. So we got find the volume of a box with these three dimensions. If you want to find volume, volume is just length times width times height. So you can do length times width times height. And I would recommend distributing the x first, perhaps. Get it out of the way. That would be 2x squared minus 6x times a 3x plus 1, which you would then just FOIL as well like normal. So 2x squared times 3x is 6x to the third, because you add your exponents. 2x squared times 1 would be 2x squared. Then negative 6x times 3x is negative 18x squared. And negative 6x times 1 is negative 6x. And that, ladies and gentlemen, is that problem. All you had to do was FOIL it. Next one. This one right here. Where do the zeros lie between for the function? So where do the zeros lie between for this function? You have the choice of graphing it in your graphing calculator, but you also have the choice of using your noggin, your brain, and knowing that if it's x minus 1.5, you could change the sign to get 1.5. You could change the sign to get negative 2.1. And then if it's just x, that's 0. Okay, so that's the weird one. And if you did graph it, it would look kind of something like this. Not that it matters, because the question is asking, where do the zeros lie between? Well, it lies between negative 3 and negative 2, because that would be where negative 2.1 is. So that would be one of the answers, negative 3 and negative 2. It also lies between, I guess, negative 1 and 1 for the 0, 1, but like, oh, I don't know, negative 1 and 1. for the 0, but it goes through 0. That one is a no-brainer. So I don't like that. That's your 0. And then it goes between for the 1.5. Well, 1.5 is in between 1 and 2. Okay? So your 3 answers that you should really have would be these right here, and they relate to the 2.1, the 0, and the 1.5, respectively. We got one more, and then we're done. All right? This next one, it's saying graph a polynomial with zeros of -2, 3, and 4. Oh, I just smudged my paper. I'm so sad. So let's start with that. -2, 3, and 4. Now read that it says 4 with a multiplicity of 2. That multiplicity of 2 indicates that it is going to be bouncing off of the 4. It's not going to go through the 4. Okay? The next part that is very important is the end behavior. On the left side, we are going down. So on the left side, we do have them flip-flopped here. On the x's approaching -infinity, that's the left, we are going down. And on the right side, we are also going down. So we would need to include both of those down arrows there. And then we would need to make sure that we have our graph appropriate. So if it is going to bounce off of the 4, I would start with that first, knowing that it's going to be approaching the 4 first. It's going to bounce off of that. And then it's going to have to curve back up to go through the 3. And it's going to have to curve back down to be able to end up at this end behavior right here. And the graph would look something like this, where it's going to go through the -2, through the 3, but bounce off of the 4. And the end behavior is going to be down and down for the left and right side of it. Okay? That's going to do it for this one, everybody. I know it was a long one, but this is the big review video for the test that we have on Unit 4. Until next time, I will see y'all later. Bye.